forever to get through one section.
Okay, 1-5, solving equations and inequalities by graphing. This is why we stopped and factored, because you were going to have to graph absolute value functions, quadratic functions, and linear functions. Okay? I gave you graph paper so you can do some graphing on it. Okay? I will give you one more piece of graph paper for homework, and after that I won't ever give you graph paper again. But if you want it, you gotta go buy it.
Mr. Meyer has.
Okay, so first of all, we do sketches most of the time. You don't want exact graphs. You do not want me to say graph it. Because if I say graph it, you have to be exact. You got me? You don't want me to make you be exact, do you? No. So we'll sketch it on paper and I'll show you how. But on these, when we get an intersection, so I have use graph to solve the equation. I have negative 3x plus 20 equals 5. Okay? I need to know exactly where those two intersect. And if I don't graph it correctly, is it going to show me? No. Now, I can solve this by hand. How would I solve this by hand without graphing?
Put it to 0.
So
No, I would.
subtract 5 from each side. And
How about subtract 20?
Oh yeah.
Wouldn't I subtract 20?
And then just divide by.
So subtract 20. So I get negative 3x equals negative
15.
15. And then what?
Divide by 3.
Divided by negative 3.
So x equals 5.
So x equals 5. Okay? So we better get x equals 5 as my solution, yes? Okay. But we're going to graph it because our learning goal is to solve by graphing. Not the most efficient way or the most, well, it is accurate, but it's not most efficient sometimes. And it's not the most accurate if I don't have a graphing calculator or if I don't have graph paper, is it? So, over here on this side, this is a linear equation, yes? Mm-hmm. It is in y equals mx plus b. Yes? So we need to make ourselves a coordinate plane. So give yourself an x-axis.
Unlike the whole graph.
I don't think I would make the whole graph. I would make a little, because you've got a bunch. I'm not giving you 16 pieces. Okay. I don't care if there's arrows on both ends, but there has to be arrows on the positive x and the positive y. Got it? So, what does this negative 3x plus 20, how do I graph that?
Negative 3.
So it starts at 20.
It starts at 20. So we're going to count by twos
How'd you figure that out?
because it's y equals mx plus b. Plus 20 is your y-intercept, yes? Mm-hmm. I'm counting by twos.
Okay.
So it's 5y.
6, 8, 10, 12, 14, 16, 18, 20. Blade, we're not worried about the right hand. Just the left hand. Okay? We're just graphing the left-hand equation right here. Okay? The y-intercept is what?
Can I save the graph paper?
Yes.
Or do you want me to
I
do
don't
this?
care.
Okay.
Okay. So now I count my slope. What's my slope?
Negative 3 over 1.
Negative 3 over 1, and I counted by twos, so I can't go 3. That would be weird. So could I make it 6 over 2?
Yeah.
Is 3 over 1 the same as 6 over 2?
Yeah.
Yes.
Yes. Okay. So I'm going to go 2, 4, 6, and over 2, and I went down. Why did I go down?
Because it's negative.
Because it's negative, and I do it again. I do it as far as I can on my graph. That's just me. I'm weird. And if I go up 3, I have to go left 1, don't I? Mm-hmm. Okay. The reason why I go is because I don't have a ruler on here. And if I go to draw this straight line, I always drive it all wonky. And I don't like to draw a wonky line, do you? It infuriates me. So, did we graph this left-hand side? We got it?
Wait.
No, I haven't finished it. What? 2, 3.
Wait, you went down 6
Yes.
and over.
2.
Wait,
Wait,
But I counted by twos, so down 6 is only 3.
How many do you go down?
1, 2, 1, 2, 3, 1, 2. But what about that 5 you were talking about?
Okay, we haven't done it yet.
Oh.
We only graphed the left-hand side. You graph the left, you graph the right, and where they touch is the solution, yes? Yes.
This is my.
Mm-hmm.
Couldn't you? Because I did my graph by fives, but if you multiply it by 5, you could do 15 over 5.
Yes. You just, as long as you multiply the numerator and denominator by the same thing, you're all good.
How?
Okay,
Should be on half line, then line, then half line, then line.
it depends how you could. I made mine 6 over 2 instead of 3 over 1, so it just depends how you did it.
Yeah.
You did by 2s too.
I did like 6.
No, because your graph goes by 2s.
Yeah. So 2, 4, 6, 2,
You
or
have to
2. I thought you went over 2, didn't you?
No, I went over 1.
You told me 2. Now
Yeah, well, 2 is 1 because we're counting by twos. Okay, now I have to graph this side. What is that?
5.
5.
It's on the x-axis.
It's what kind of a line is 5?
X.
Yes?
parallel.
Horizontal.
Horizontal.
Shut up.
Well, it's parallel to the x-axis.
Yeah.
Okay, so 5, and since I counted by twos, I'm going to be in the middle, yes?
Okay. 1,
2, 4, 5,
1, 2,
yes? And it's going to be 5 all the way across? Isn't it going to be 5 all the way across? It,
it will because nothing's stopping it.
nothing's stopping it, and all it is what?
A line.
5.
You guys, does my graph look better?
That looks amazing. You want us to graph the line, not graph it? Okay, is this all we're doing today? Is that
No.
great?
Obvious.
Every problem looked like this, that'd be
'Kay.
awesome.
So where do these two intersect? I need this point right here. 5, 5. So the solution is
5, 5. Wait, what? So we could just win at 5, 5. The answer is right there.
well, that's the intersection point, isn't it?
Wait, yeah. And then
You
2,
confused.
4, 5. Wait, 2, 4, 6, 5.
How'd you know to go up 2.5? Where the horizontal line is?
Because this is 5. It says over here it says 5.
Yeah.
So that's y is 5. So I'm counting by twos.
2.
So 2, 4, 5.
It's. Oh yeah.
Got it?
Yes, Miss May.
Okay, let's do it again.
No, not again.
Okay, we're going to graph the left-hand side. We're going to graph the right-hand side.
Okay, I know where the 3 goes, Miss Mick. That's about Oak Creek.
This one I think we can count by ones, don't you?
Yeah.
So the left-hand side, the y-intercept is negative 12. Oops, I better pick a different color.
So y-intercept is negative. Are you kidding me, Miss Mick?
Okay, right here. Okay, y-intercept's negative 12. Yes?
Yeah.
And then what is my slope?
3 over 1 is 5
Nope.
over 1.
It's 5 over 1.
That's what I meant. I'm here.
Okay, so up 5. 1, 2, 3, 4, 5
you start at?
over 1.
12.
The y-intercept,
What's that? 5?
Negative 12.
negative 12.
Wait, Miss Mick, this has always confused me.
What?
Oh. How do you know which way to go? Like left or right?
Well, okay, you need a positive number. So if I go up, I have to go right because 2 positives is a positive, yes? If I go down, I have to go what? Left because 2 negatives is a positive.
But didn't we go right on the other one?
Because it was negative. We had to go one negative direction.
And then you went up 5 over 3.
No,
Oh.
the slope was 5 over 1.
My graphs are a little tiny, so they might be a little messed up.
Okay. You guys got your 5x minus 12 line? Okay. So now what is the right hand side?
3.
3. And that is a
Horizontal.
horizontal line. At what?
At 3.
At 3. So at 3, make a horizontal line.
Just make a little weight with that.
I'm already done.
What's your answer then?
3,
3, 3.
I thought you were going by twos, not on this one.
Not on this one.
Okay.
If you went by 2s, that's fine. You're still going to get 3, 3.
How do you get 3, 3?
Well, because they intersect right here, which is where?
This is kind of good now.
Yeah, I'm kind of good now. I've actually been.
Wait, so how do you get the slope?
It's the coefficient of x every time. Guys, this over here is y equals mx plus b, yes? And b is the y-intercept, m is the slope.
Okay.
Okay, so my answer is what?
3,
3,
3.
3. Ready to be challenged?
Oh, no.
No.
I'm not.
I don't like
Get it.
And that's where.
Okay, so we're going to graph the left, and we're going to graph the what?
Right.
Right. Okay, so give yourself an x-axis,
How big?
y-axis. Do not be doing your work on your graph paper. Do your work on your paper.
Oops.
Like you can graph on your graph paper, but if you have any work, don't put it on there. Don't use it for that.
What about the like answer, like where it intersects? Is that fine?
It doesn't matter. I don't care. Okay. So what shape is the left?
Oh, a progalogola.
A parabola?
Yeah.
Okay. So in order to get a in order to get a parabola, we probably need to find the x-intercepts, which are the solutions to the parabola. Yes.
Why do we?
What did we do all day yesterday? Finding the zeros. You found the zeros of the parabola. Yes. That's what you were doing. X-intercepts, zeros, and solutions are all the same thing. So we need to set, this is just x squared minus 4. Set it equal to what?
0.
0.
Okay, well, what
There's-
is greater than 5?
Just don't, we'll worry about that in a
Don't
second.
interrupt her.
Worry about that for a second. Okay, now I'm going to add 4 to both sides because there's nothing to factor, is there? Nope.
No.
So this is exactly like number 1 on your worksheet. What did we do? Then let's take the square root of it. So x equals what? 2 things? 2 and negative 2. So at 2, oh, I need a different color. At 2 and negative 2,
There will be no open gym
okay?
during IAC today. However,
Because, okay, what is 2 squared, guys?
may come down.
Well, no, what is 2 squared?
Austin March,
4. What is negative 2 squared?
Kel Ames, Brandon Carmichael.
2 squared
Please
is
see Mrs. McKinney
4.
During IAC.
Negative 2 squared is,
All senior football players. will
negative 2
stop
times
by the
negative 2
office.
is 4. That's how you get plus and
Softball
minus.
class will meet today during
Okay.
IAC.
So now,
309.
a parabola is symmetric, correct? It's the same on the left and the right? Yes? Isn't 0 right in the middle?
Yeah.
So I need to figure out how far the y goes down when x is 0. So I plug in what? 0. So I get 0 squared minus 4 is what? Is negative 4. So at 0, negative 4, I put another point. And this isn't exactly important for what we're doing today, but I just wanted to show you. Okay, so then we draw our parabola, right?
Are you going by twos on this one?
Did you
Nope.
put 0 and 4?
Yes, I put 0 in for x. Okay. Now, when you guys were graphing these last week, I said check a point inside the parabola and outside the parabola, yes? But this statement, I want you to look at this statement. It says, when is this greater than 0? What does it mean to be greater than 0? It means above the x-axis, which also means positive, yes?
Yes.
So it's positive where? Over here and over here, correct?
Yes.
So where does over here start?
Infinity.
What kind of infinity?
Negative.
So negative infinity
The positive infinity.
to what? Nope. Where does it stop? To negative 2. Okay? And leave a space between. And then it's going to pick back up at where? Oh, wait. Yes, a 2. Sorry. And go to where? Positive infinity. Now, in between these, this is an and situation, yes? It's left and right.
Yeah.
So you put a union. You put a U for a union. When you do your IXLs, if you don't, or your math excels, if you don't put that U there, they're going to count it wrong. Because it is an and situation, isn't it?
Yes.
Now, before I told you to check a point, well, let's check 0, 0. Ready? 0, 0. So 0 minus 4 is greater than 0. Is negative 4 greater than 0? No. So it's not in here. It would be where?
On the outside.
All of this out here. Get that?
Oh wait, you just put the 0 in for the.
I just put inside and outside.
Oh,
Okay. So, do I have another parabola?
okay. Yes, you.
Yes, I do. So I need to do what with this over here? What did we spend all day yesterday doing? Finding our factors. Finding our x-intercepts, our zeros. So factors of 5 that add to 6.
5 and 1.
5 and 1, yes? So I'm going to use my second method I was showing you today earlier. So only factors of x squared are what? X and x. And the only factors of 5 are 5 and
1.
1. And they're both what?
Positive.
Positive. Okay, then I set them both equal to what? 0. And so x equals negative. Okay,
Does
So-
it matter which, like,
you should put the smallest one first, and I'll show you why. Okay, so I give myself an x-axis, yes? And I give myself a y-axis. So my zeros are at where? Negative 5, 2, 3, 4, 5. And negative what? 1. Now, I could figure out my vertex. It would be at negative 3, but do I really need it? No. So I'm just going to graph my line. Does this open up or down? Up, because this is positive over here, yes? So here it is.
Wait, don't we have to get our endpoint?
We don't have to. We're not going to. That was just something we did. We could. If we plugged in negative 3,
so if we just get those 2 points and then.
yeah, you're good for right now.
Okay.
4 now.
Okay. So we're here, yes?
Yes.
So I want to know greater than equal to 0. So positive. Where's that at?
The left.
Over here.
Infinity to 5 and.
Okay. So negative infinity
Oh, shut.
to 5, negative 5, but at negative 5, shouldn't I have a bracket? Not a parenthesis this time?
Why?
Because it's included.
Wasn't the last one included?
Nope. The last one was just greater than.
What is it?
So
The last one was greater than. This one is greater than equal to.
Oh, I understand.
Okay. And then what goes in the middle?
The unity.
The unity. And then it picks up where?
Negative 5.
At negative 1.
Is that included?
So positive.
Yes.
That's a That's a.
And that's a parenthesis. Okay? So make sure you have your assignment.